But I'm still grading the test. Okay, about half of them is done. It's pretty slow because I have to check each problem carefully, give partial credit. So if you really am in a hurry to see the test scores, you can email to me so I can check out first. But today I'm going to discuss the material in chapter 10. Okay. So this is about parametric equations for the curves, and then how do we use that to still have to compute the length, and then also the area of the surface of the revolution generated by curve. At that time, the curve the curve is described by two equations. We call the parametric equations. Okay. And then we also will study polar coordinate. All right, so the first example, let's take a look at the graph, right? Y equals x cubed, okay? X is between 1 and 0 and 1. So the graph is a curve, okay? The graph is a curve, okay? It is described by, it's determined by all the points with coordinates x and y, and the y is going to be x cubed. Okay, y is not an arbitrary, otherwise you're not going to get a curve. Okay, so this is the 1 and the 1, right? Here's a 0 and a 0. All right, so this is a curve, consists of all the points with coordinates x and y, and the y, either y depends on x or x depends on y. Okay, so actually this is a curvature equation, y equals x cubed, and also y x is going to be y to the 1/3. It doesn't matter which one. All right. Now we're going to find another way to describe the curve. We can describe curve as an orbit of a moving object that depends on time t. So here's another way to parametric equation. Okay, so x depends on time, not y variable. Okay, so x is going to be a t. Okay, for example, and the y is going to be t cubed. Okay, t is between 0 and 1, and you will get the same result. So you let the t changes from 0 to 1, and then x and y both change, right? And then you get a point, a moving point in the xy plane. And that moving point, the orbit, is going to be in the curve, okay, which is the graph of y equals x cubed. Then, the point can move fast or slow, right? So there are many ways there's many ways to move and to travel from the origin to that point at a different speed, right? So another possible way to parameterize is like t equals 1/3, okay? So y equals t. That's also gives you the relationship y equals x cubed. Okay, is there any other possible way to describe? And yes, you can let x to be let's say x is 2 squared. That's fine. Y equals t cubed, then t to the power 6. T is between 0 and 1. So you will get the same orbit. Okay, if the object moves in the xy plane and according, subject to these two equations. Okay, right? So as long as I keep a relationship of y and x between y and x, y is going to be x cubed, right? Then y is t6 to t to the power 6, and then the t squared and the cube. That's why t squared is x, so x cubed. Okay, then you get the same orbit. Okay, so the parametric equations are not unique for the same curve. Right, for the same curve, they're not unique. Okay, so second example, the circle. Let's consider as a circle of radius r. Okay, and the x squared plus y squared equals r squared. This is the equation. Okay, this equation describes the circle around the origin, right? Right. Then how do you find the equation? Well, step by step, right? We know that cosine squared t plus sine squared t equals 1. This actually is a Pythagorean theory, kind of. Okay, so x divided by r squared and y divided by r squared equals 1. So you can set x over r to be cosine t, y to be equals sine t. Okay, or x equals r cosine t, y equals r sine t. Okay, now what is a range for the t? T can start from 0 and end with 2 pi, so you get the same point. Okay, so you get a complete circle. You get a complete circle. Actually, in fact, T is the angle, okay, formed by between the x-axis and the line from the origin, right? Passing through x and y. So this is a point. Right. So this is a very natural parameterization. Are there other parameterization? Parametric equations for the same circle? Yes, the answer is yes. There's just so many different ways to do it. Okay. So I can also give you here's r cosine s divided by r. Okay, and y equals r sine s divided by r. Okay, now this time s is between 0 and in order to get a complete circle, s, the upper bound for the s should be 2 pi r. Okay, because s 2 pi r divided r is 2 pi, right? So you can use a substitution. T is s of r, right? Or s equals r times t. S equals r times t, right? If t is between 0 and 2 pi, then s is between 0 and 2 pi. Now, what is s here? Okay, s actually is the arc length from here to here. This s. Okay, we use the arc length to tell the location of the point on the circle. Okay, the arc length is determined by the angle T and the radius R, right? Remember, right? So there are many ways to describe the same curve in the space. Okay. Now, next, we're going to describe yeah. How about the strict line? Okay, the strict line in the space. Okay, how do you describe it? So you have a straight line, right? Okay, so the equation is y equals mx plus b. That's a typical one. Okay. Right. Got the easiest parameterization is let x to be t, then y is mt plus b. That's fine. Right. Right. Now, sometimes m is a fraction. Okay, then you have you do have multiple choices. You know, you can let x to be, how about let x be 3t, right? Yeah, or let x to be, you know, yeah. So there are many ways. For example, x to be 80, right? Then y is now going to be 0. Then y should be m over 80 plus b. That's another option. Okay, so it's not unique. Okay, and these two equations also gives you the same relationship between x and y. Okay, because t over a is x, so you can replace t over a by x, then get y equals mx plus b. Okay. So they are using vector geometry. Okay, you can describe it in a slightly different way. So you take an arbitrary point. Okay, that's called x naught, y naught. Okay, and then the direction of the vector. Okay, that direction that's called a and the b using. Okay, so x and the y is going to be, this is the arbitrary, right? And somewhere here, x and the y. So this is going to be this point plus a multiple of this vector for the line. So that will be t and a and b. Okay, right? Then see, how do you get this vector, right, from the origin to that point? Okay, let me draw these different colors. This is what I want, right? Okay, and this is our vector here. You have to scale it. Yeah, you have to scale, you know, times this, yeah, this part will be t times a. Okay, then you get this, then you get the vector between those 2 points on the line. And so add them together, you get the vector, right? So doing this, and then you can get x naught plus ta and y naught plus tb. Okay, so x should be x naught plus ta, y equals y naught plus tb. Okay, so you have to find out the vector and the arbitrary point on the line. So this is another way to parameterize, to find the parametric equation for the line. Okay, and what is the slope? The slope is actually is going to be b over a. Okay, the slope, right? The slope m is going to be, I think, a b over a. Okay, it's determined by b over. Okay. So conversely, if you know the slope, if you express it in the form b over a, then you can write down using u and a and b, and to write down the parametric equation. Okay. Now let's see why it is like that. Okay. Let's try. Okay. Y equals right. I'm going to replace t by something, right? So from here, from top, right, x minus x, right, is going to be divided by a is going to be t, right? That's from first equation. Right. Okay. So t is going to be a x minus that b, right? So let's see. Okay. So we continue. Multiply this out. Okay. So you will get b over ax plus y naught minus b over ax. So this is a number. This is my m, right? So that's why the slope is b over a. Yeah. Okay. Right. So let's take a look at next problem. We are given t squared plus t, y equals t squared plus 2, and t is between -2 and +2. We want to sketch the graph, sketch the curve described by this parametric equations. It's not a graph. Okay. It's harder to find the relationship between x and y. If possible, then that'll be very helpful. Okay. So even we find a relationship, we probably cannot even sketch graph based on the equation in x and y because it's complete. Right? So how do we do that? The traditional way. Okay. You have to choose a t value and compute x and y. Okay. As many points as possible. Okay. Let's choose the negative. The -2 must be included, right? The -1, that's the first step. Right? 1 and 2. Maybe sometimes additional points are needed. Okay. So you plug a -2 for t in x. So 4 minus 2, that's 2. And -2 squared plus 2 is going to be 6. Then -1. I think this is going to be 0. -1 squared plus -1. -1 squared plus 2, 3. That's 0. That's 0. That's 2. And plug 1. That's 2. It's 3. And then when t equals 2, that'll be 6. When t equals 2, that will also be 6. Okay? So we get a bunch of points. All right, let's see. We also have the starting point and the ending point. Okay. Let's draw the picture. Okay. Where's the t and where's the 2 and the 6? 2 and the 6 is pretty high here. It's 1 and the 2. Okay. 4, 5, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Oh my God. So 206 is here. Okay, here's 1, 2, right? Then 0 and the 3. So 1, 2, 3. Okay. And then 0 and 0. It's here. Right? That's when t goes in. And then 2 and 3. 2 and 3. It's here. Then 6 and 6. 2, 3, 4, 5, 6. 6 and 6. So I think, okay, I think it's going that direction because that's what you see, right? Okay, then there's a part is missing here. Right? We don't know how between those 2 points. Right? We really needed to find out another point, which is on the maybe in the second quadrant, right? So how can I find this point? Where's my file? Okay. All right. So yeah, we have to find that point. I think we should at least try when t equals 0. This when t equals between t -1 and 0, right? We have the guidance point, right? Between t is between -1 and 0. So this is the area we don't know. We wanted more details. Okay. The best I have to find the sum if it's going like this way. Okay, imagine, right? So x has a minimum value. So this is how far it can go on the left side, right? So this is what I'm trying to do. Okay, x equals t squared plus t. So I'm going to look at this graph, t and x. Okay, so that's the t plus 1. It has 2. When t equals 0 to 0, when t equals negative it's -1. So this is a graph for this equation, x equals t squared and t. So clearly, x has a minimum value when t equals -1/2. Okay, so I think we should choose -1/2. Okay? So when t equals -1/2, x is going to be -1/4. Okay, -1/2, and this is a point. Actually, the value is going to be -1/4. Okay, you can calculate. So x is going to be -1/4. So what is y? Y is going to be -1/4. It's part of quarter plus 2. So which is going to be 9/4. Okay. Okay, and where is this point? It's slightly bigger than 2. Right, slightly bigger than 2. Okay, so it's somewhere. If we have to draw the graph, yeah, let me sketch it. Right. So here, somewhere here, it's a 3, and this is only a tiny bit. I think. Okay. So this is a graph, and And this is a point, -1/4, 9/4. And this is a point on the left-hand side, the farthest point they can get. Okay, so I think then this is a really, good picture. If you really don't know, you just pick up a point between -1 and 0, the middle point, either one point. So you can get another point, then you can get a much better picture. That's it. Okay. So at the end, maybe additional points you need to be added. Okay. So my next question is x equals t squared. So y equals t to the 4th power. T is between -1 and the +1. Okay, let's sketch this graph. Well, -1 and the +1. So only have 3 points here, right? You can choose t here, -1 and 0 and the +1. Probably we have to add more later. It's been, if we feel difficult to sketch this graph. So when it's -1, it's 1, 1, 0, 0, 0, 0. Okay, it's very difficult based on this information to sketch the graph. Okay. Now we need either add more points, or we try to see if there's any simple relationship between x and y. So y equals t to the 4th power, so it's t squared, so that's just x squared. So this should be the curve is a portion of the parabola. Okay. The curve is a portion of parabola. That's the first information. The second information I needed, x is greater than or equal to 0. Okay, x is greater than or equal to 0. Okay, that's also important to see. Okay, based on all this data, I can sketch the graph. Okay, when t equals -1, I'm here. When t equals 0, I'm here. Okay, so this is a portion of the parabola. So the point must, this object must move around this parabola. And then when t equals +1, it's back to here. So I imagine you just make a U-turn and going back to the same location. Okay. Since x is always greater than or equal to 0, so it's the graph never good. The curve is only on the part in the first quadrant. Okay, that's the information. You don't need to add more points to waste time to the calculation. Okay, you based on this information, that information, and the third one. Okay, and you can get a picture. Okay, draw the graph for you. Okay. Yeah, let's consider next one. X is t squared, y is t cubed, and there's no restriction on t. Okay, let's try to sketch the graph. Okay, I think what we have to, what you know is from here, x is always non-negative, right? Y changes signs. Right? Right? This keep in mind. Can we get a relationship between x and y? I think you can solve for t from the second equation. The first equation have trouble, have a plus minus square x. So using this, then you get the relationship. X equals y to the 1/3, square is y to the 2/3. Okay, now what kind of equation you're going to get? So in general, okay, here's y equals x to the alpha. Okay, the equation looks like that, as the graph looks like that. If alpha is what should I say? If alpha is greater than 1, it looks like a parameter. If alpha is greater than 1, okay? If alpha is x1, if alpha is less than 1, okay, in that case, okay? So our example, so x equals y to the 2/3, the graph looks like that. Okay. So the curve determined by the parametric equations must be portion down. Okay. Maybe the whole graph, right? So the curve, okay, must be a portion of this this way, okay, of this graph. Okay, so let's see. And clearly, when t is negative, y is negative, right? When t is positive, y is positive. When t equals 0, it's 0. So I even do not change them. I don't need to even choose a point. Okay, so when t goes to infinity, it goes in a direction. T goes to infinity. And this t goes to negative infinity. Okay, so this is our picture. That's it. Now, if you really want to know the precise information, here x and y, and you can choose let x to be -1, 0, 1. That's enough. Okay, when x equals -1, it's 1, 1, 0, 0, 1, 1. Okay, same point. This is a negative here. 1, -1. Here's 1 and 1. And this is 0 and 0. You get, you just draw 2 points, 3 points. Okay. All right, the second one, here's another similar one. This one, it doesn't matter which one you want to solve, right? So you can solve for t from the first equation, and then you put into the second equation, t cubed, x to the 1/5. Okay, so this number is smaller than 1, okay, just like a square of x. So the graph looks like that. But x can be negative, okay, because 3x to the 3/5 is defined for negative x. So this is a graph. And when t is negative, x is negative. When t is negative, y is negative. Okay. So you can get, this is the first thing. You can get the equation. Second, x and y both change signs. Okay. When x changes signs. Right. When t changes signs. Yeah. So when t is negative, x is negative. And also, x goes to infinity, both x and y goes to positive infinity as t goes to positive infinity, right? And those goes to negative infinity as t goes to negative infinity. So I think this is a whole graph, okay? From negative infinity to positive infinity. You can also choose, here's t equals 1. When t equals 1, you get 1 and 1. When t equals negative 1, you get negative 1, negative 1, okay? So the graph passing through these 2 points. Let's say you don't need to plot too many points to get the graph. All right. Here's another question. We are given this equation, this parametric equation. Trying to sketch the graph. Again, you can find a relationship between x and y. Okay, how do you do that? Well, from the first equation, cosine t is 2x, right? From second equation, sine t equals half of 1. So that means x and y must be related. Okay, right? This implies. So this is x squared, 2 squared. So I can express in this form. And the y squared divided by 2 squared. So it's ellipse. So the graph, the curve is a portion of this ellipse. Okay. The curve is a portion of the ellipse. Right? Maybe the whole ellipse, right? Right. So the ellipse, how do you draw the ellipse? Quickly. Well, you let the y to be 0. X is going to be what? It's going to be plus minus 1/2. So this is 1/2. Then you let x to be 0. Then y is going to be plus minus 2. So this is the ellipse. Okay. And then how do you draw the graph? Okay, so you and then pick up cut points, right? T's I know at least what I want to see where is it, right? So here t and xy, right? T start from 0, maybe middle point, maybe, right? So 3 points should be enough. Okay, when t equals 0, I get 1/2. X is 1/2, y 0. When t equals pi over 2, I get 0, y equals 2. Then when t equals pi, then I get negative 1/2 at 0. So this is the point t equals 0. This is the point t equals pi over 2. This is the point t equals pi. So this is the graph. It's going that direction. And you can have the orientation. All right. All right. Yeah. So this is just half of the ellipse, right? So I'm going to ask you to do the following problem. Okay, similar. Okay. Find the parametric equations for this ellipse. Okay. X squared over 3 plus y squared over 4 equals what? Okay. And try this. Yeah, try to write down the equations for this ellipse. Right. So again, like this is this can be written in the form x over square 3 square plus y over 2 square equals 1. So this place x over square 3 should be equal cosine t, y over 2 equals sine t. Okay. Then x is the square of 3 cosine t, y equals 2 sine t. Okay. T, well, if you just want to complete the ellipse, then you get t is between 0 and pi, 2 pi. Okay. How about this more complicated? Find the parametric equations for this one, x squared, okay, plus 4y squared minus 2x plus 4y, and plus what equals 0. Wow, this is tough, right? Right, so the very first step, you have to rewrite, express this equation in the standard form. So your x squared minus 2x is here, 4y squared plus 4 is here, and equals -1, right? So you have to add some numbers. Right. So I think you just add the 1 here, add the 1 here, then add 2 here on both sides. Okay, so this will be x minus 1 squared. This will be 2y plus 4 squared. This will be 1. Okay, that's it. So again, this is a squared, right? So clearly, x minus 1 should be cosine t. 2y plus 1 should be sine t. Okay. Right, then cosine square plus sine square equals 1. So x equals cosine t plus 1, y equals half of sine t plus 1/2. T is also from 0 and 2 pi. You can get the complete circle. This is ellipse actually. It's ellipse, but the center is not at the origin. Right. The center is not at the origin. Now this time we are given x equals sine t, y equals cosine square t. T is between negative 2 pi to positive 2 pi. Wow. Okay, let's try this. I think there's a simple relationship you can try first between x and y. So y equals cosine squared t, which is 1 minus sine squared t. And sine t is x, so 1 minus x. So this graph will be portion of this parabola. Okay, this is a parabola, right? Here's a 1, here's negative. Okay. And t is from negative 2 pi to positive pi. I think, you just need to begin from 0 to 2 pi because they're both function, periodic function. It's still repeating. Right? Or you can start from negative 2 to positive 2. Okay. So t and x and y, right? So this is negative 2 pi. And maybe negative 2 pi, negative pi, right? Maybe 0. Okay. So this is then it's repeated. Okay. When t equals negative 2 pi, that's going to be 0. X is 0. Y is going to be 1 always. Okay. When t equals pi, it's also 0. Well, it's not good enough. And then that's just 1. And that is when t equals 0, that's still 0. Okay. And that's just 1. Okay. So you get all the points at the same point. Right? So clearly, I just say you just need to draw the graph for t between negative 2 pi and 0 because, and the next step is between 0 and 2 pi, just repeat it. And maybe going around, right? Yeah. Okay, so more points are needed in order to get a better picture. I just add additional here, x and y. It's negative 3 pi over 2, right? Right, between negative 2 pi and pi, that's 3 pi over 2. So here's pi over 2, negative pi over 2. So negative 3 pi over 2, cosine negative 3 pi over 2. Negative 3 pi over 2 actually is a sine, right? Negative 3 pi over 2, it's going to be 1. Be careful about it, okay? And this is going to be 0. Negative pi over 2 is going to be negative 1. And that is also still going to be 0. Okay, now it's slightly better. So when t equals negative pi over 2, we are here. When t equals negative 3 pi over 2, x is here, right here. So negative 3 pi over 2. When x equals negative pi, I'm back to here. When t equals negative pi over 2, I'm here. Okay. When t equals 0, I'm here, back to here. So now it's clear. So this is going to be like that. Go in here and go back. Right? And come back to here. No one, Okay. So basically it goes like that, and then going back, and then continue like this. Right? Yeah, back forward. All right, right, so this is a little bit complicated, but when you draw the curve with orientation, at the very beginning, maybe only choose 3 points, right? But sometimes it's very difficult to sketch the graph. Now, even with the help of the equation x, y, then just add a couple more points. Okay. Now, without the graph, without the equation, okay, the equation we have is without the equation y equals 1 minus x squared. I think this 5 points is not enough, right? You still have to maybe choose a more values of t to calculate x and y, and then you have more points. Okay, even that is still hard. You just by guess, how does the curve look like between 2 points? Okay, so trying to find a relationship between x and y, and then you recognize this is a quadratic equation, maybe some simple equations, so you can easily sketch the portion of the graph. Okay, the next step is just choose values for t, so you can get few points. Then you can find out where's the starting point, where's the ending point, and then still not very clear, then add more points. Okay, add more values, choose more values t, and calculate the corresponding coordinates, x, y coordinates. Okay. So let's do one more problem. So x equals tangent theta, y equals secant theta. Theta is between negative pi over 2 and the positive pi over 2. Now, let's see. I want to make sure that they're defined, right? Tangent theta is defined, yeah, because tangent theta and secant theta, they're both cosine theta in the denominator, right? So cosine theta is always defined, okay? But clearly, when theta approaches pi over 2, x approaches infinity and y approaches infinity. So as theta approaches pi over 2 from the negative side, x approaches positive infinity, y approaches positive infinity. Okay. So when x approaches negative pi over 2, okay, from positive side, then our x is right? Wait a minute. Yeah, x is sine theta approaches -1. Right? So that's why this would be negative infinity, and the y still is always positive. So the graph, x is from negative infinity to positive infinity, and the y value is always positive, right? So you can see that x is from negative infinity to positive infinity, y is always positive, never be negative. So this is a graph above the x-axis. Now, let's try to find the relationship between x and y. The relationship between x and y, it's not easy to find out, but I know that tangent square of theta plus 1, right, is going to be secant square theta. So that's a relationship. So x squared plus 1 equals y squared. Okay. So we get y squared minus x squared equals 1. Now this is a hyperbolic equations. This is a hyperbolic equation. Okay. So the graph is a hyperbolic. How can I find out? How can I quickly draw the graph? You let x to be 0, y is going to be plus minus 1. So this passing through those 2 points. Right? So this is a hyperbolic. Looks like that. But our graph say y is greater than 0, right? So clearly, this is my graph. Okay, okay, it's going in that direction because when theta is negative, x is negative. Okay, it's going this direction. So you can use the trigonometric functions to describe that curve, right? We also have the equation. I remember, right? Hyperbolic. That's why I call it hyperbolic function, right? Minus. I think this is also an equation. Remember, right? Right. Yeah. So for the same equation, I can let x to be hyperbolic sine t, y equals hyperbolic. That's why, you know, this function called hyperbolic sine t, hyperbolic cosine. Okay, t's are from negative infinity to positive infinity. So this is another parametrization for the same curve, right? For the same curve. Okay, so there are 2 different ways to describe the top piece of the hyperbolic. Okay, when t goes to negative infinity, x goes to negative infinity, right? Y is always goes to positive infinity. Y is positive. This is always positive. Okay, so for the same curve now, we do have 2 interesting parametrization. Okay, one is this one, and the theta is between negative pi over 2 and positive pi over 2, and here t is from negative infinity to positive infinity. Now, I'll give you an example why we are interested in parametrization, okay, parametric equations. For example, if we use the parametric equations, you may be able to simplify the computation when trying to find the length. Okay, find the parameter, for example, circumference, right? Find the length. Okay, I just find the length of the curve. Okay, of the curve. Okay, the curve is actually it's just going to be x squared plus y squared equals r squared. You know the formula, right? And the complete circle. Right, this is a simple application. So what you do is you find the parameterization cosine t, y equals r sine t. T is between 0 and 2 pi, so you get a complete circle. Right? So remember, the length is the integral of ds. Now, what is ds? ds at the very beginning is dx squared dy squared, right? So you can, if this is a graph of function, you take dx out or take dy out. This time, I'm not going to take dx out, dy out. Dx are divided by dt. And then put a dt here, right? Formally, you can move dt inside and cancel dt, right? And the t's are from 0 to 2 pi. All right, the derivative of x with respect to t is going to be r negative sine t. The derivative of y sine t is r cosine t squared dt. All right. Right. Then you simplify it. So you get r squared sine squared t, r squared cosine squared t dt. So sine and cosine add them together, it's going to be 1. And then r squared is just r. See, this is a constant. That's a 2 pi r. So that's why how to get the circumference of a circle so quickly. But you have to use a calculus. Calculus was was created, actually, was introduced by Newton and another guy called, I forgot, Ellipse, I think. This is the same time, about the same time. The ideas, the notation, like dt or dx, okay? This is a really very powerful tool, okay? In the human history, okay, there was always some few of them. Yeah, they did a great work. Right now, our knowledge expand exponentially. There's so many directions. So scientists cannot know all the areas. But the early days, 200 years ago or 300 years ago, many scientists actually know mathematics, engineering, everything. They can do all kinds. So you can find the name in the different areas, like Newton. He's famous in mathematics. He's famous in physics. Okay. And even Albert Einstein. I just look at his original article published. And you look at the article, you find out that he has a knowledge at least at the master degree level in mathematics. Okay. And so it's hard, he's a physicist. Okay. Right now, very few physicists have a master degree or PhD in mathematics. Okay, because there's so much material they have to learn from that. Just focus on. If your knowledge is very narrow, then it's very hard to do great work, honestly. So even these days, if someone be able to understand, has knowledge in both areas, and not necessarily in 3 areas, then you really can be more creative. Think about the imaging process applied in medical science, right? If you have a knowledge you know, at least at the undergraduate level, bachelor degree in mathematics, right? And the master degree in engineering, and then maybe MD in field, you know, in medical, you know, school from medical school, right? You probably can do some good work in this area. Okay, because imaging processing involves geometry, right? And even computer science, and you should know how to program it. All right. So I just give an example too, and this class, stop the recording here.